Flat Earth research. Something that somebody told me that I really should do. Because they said, well, my held beliefs, if I just go out and test them, it would show that it was flat and not a globe and all that sort of stuff. So I decided to go out around the San Francisco Bay, take some pictures of birds, bridges, buildings, the bay, anything else I could think of that started with a B, occasional boat. Here's the question, where is the curve? And so I went to the San Mateo Bridge. Actually, I'm on the other side of the San Mateo Bridge from the flat, straight section, which is called the Causeway. And I took a picture of the causeway. This section is 5.1 miles long, and it's very straight and very level. However, it looks very curved. If you put some lines on there, you can actually see there's a curve. I went to the online calculators, and it tells me I should see a drop of 16.7 feet. So that people misunderstand what that drop is. That's not the curvature, but it gives me a rough idea that I should see a 16.7 foot drop from the horizontal. And, I can't really tell from this picture, but one thing I can tell from this picture is that it's curved. This is what it looks like from the air. You can see it's a long, straight section, and it's very level. There's no reason for them to be trying to put some kind of weird curves in it. And then there's the question of things disappearing over the horizon, which is another question. Is that things don't disappear over the horizon, except that they do. And here I have San Francisco partially submerged here on the left, probably 300-400 feet of the city missing. It went somewhere. On the right here, I have a picture of the same city, a little bit different angle. You can tell. You can see some of the buildings have rotated a little bit, but some of the landmarks are very obvious. And you can see a lot more of the city. This was taken from just south of the San Francisco International Airport to give you some reference on a map. Obviously a lot closer to the city. The one on the left was taken from the Dumbarton Bridge, which is pretty far away. And here's a few pictures of a bunch of other things that have been hidden by the horizon. KGO towers there in the center, and there's Asia up there in the upper middle there. I can't really see Asia. If you can, kudos. And then there's the question of the horizon always rising to eye level, except that it doesn't. So I was up on the hills, again in San Mateo, looking down at the ocean, and the curve calculator told me that I should see about a 0.9 degree dip angle to the horizon. And I measure about a degree. I'm gonna, okay, all right, that looks pretty good, but a degree, come on, that's pretty small angle to try to measure, especially with a phone theodolite and its IMUs and such. So I went up on an airplane. This is on a trip from Seattle to San Jose. I'm flying over Clear Lake and Lake Berryessa. So I know the Sierra Nevada is about 135 miles away. The horizon should be 222 miles away. And the horizon dip should be about 3.2 degrees, according to the curve calculator. Well, here I snapped a picture out the window, and I'm looking down at the horizon like you always do on the airplane. About 3.3 degrees. Those are the mountains poking up above the theodolite line. That's the Sierra Nevada mountains. You have to look down on them to see them. So, the horizon does not rise to the eye level. Went down to the beach just to verify that. Make sure the thing actually works. You never trust these things. And I got 0 degrees. It's pretty much at eye level at the beach. At least it's very hard to measure. You're not going to measure it with a phone. So that's been my experiment so far in the flat Earth. You can tell me if I'm doing something wrong. I don't know that I am. In the meantime, here's some CGI I took with my telescope. It is CGI, right? Even though I can look through and see these things through the camera lens. It's obviously CGI. Thanks for watching. Good luck.